Hello, welcome back to this journey into DevOps. My name is Dare and I'm so excited you've made it so far. In this video, we are going to be talking about how to install software on Linux. To get the best out of this lesson, first we need to get some terminologies out of the way. First, libraries or modules, package or software, dependencies, package manager or package management system, command line utilities, repositories, compiling a software, binaries, script, file extensions. Number 1, libraries and modules. Sometimes you find these two used interchangeably, even though sometimes they may be used to mean the same thing, but we do need to understand the difference between them when it comes to Linux. In programming generally, libraries are pieces of code that's been collected together and can be reused within the program. So for a software developer that is building an application for a game, if there are other pieces of code that's been developed by other developers that does things like running, this game developer do not need to write the running code again. All he has to do is to import the running library and use it to extend the functionality of the game he's developing. Now that concept remains the same for Linux because the Linux kernel uses modules to extend the functionalities of what it does. There are so many modules with a .so extension which the Linux kernel loads to perform certain tasks. The driver that comes with a keyboard is an example of a module that the kernel loads to be able to act on the instructions of the keyboard. So this essentially extends the functionality of that operating system. Number 2, package or software. A package is a collection of files into an archived or compressed file that helps with the installation of a software. So it's not the actual software, and it's important we talk about this so you can understand the differences. Number 3, dependencies. These are either libraries or packages that's required before a software can be successfully installed on a computer. Number 4, package manager or package management system. This is a tool that helps with the installation of software based on specified package. Number 5, command line utilities. Anytime you hear things like this, it basically means the program you run on the command line. So with ls or cat or pwd, these are command line utilities that can be used to do certain things. And there are command line utilities for installation of software. Number 6, repositories. A repository is a centralized location where all software to be installed can be found. You can either find repositories on the internet, or you can build and configure your own private repository within the server's network. Number 7, compiling a software. It is important to understand that the code written by an application developer is not exactly what the computer understands. Computers generally understand just binaries, zeros and ones. And so for the computer or the operating system to interpret what the developer is writing, there has to be a way to compile that code into a language that the computer understands. Number 8, which is binaries. Binaries are the compiled version of the code. Number 9, script. A script is just a simple text file that contains commands in which, when executed on the computer, is able to perform instructions as written in the file. So the major difference between binaries and scripts is the fact that scripts are text files that you can read as a human, but binaries have been compiled only to be readable by the computer. And number 10, file extension. Anytime you hear the word extension, it basically means the characters used after the last dot of a file name. This helps to identify the type of file we're working with. Now that we have all these terminologies out of the way, we can actually talk more about how to install software on Linux. So let's get started. First, let's go back in time. Before we see how software is being installed in modern day, how was it back then? Because installing software in Linux has come a long way. Historically, software used to be distributed through either FTP, which is a file transfer protocol, or mailing list, which usually contains an archived file with the .tar extension, which when extracted will contain a few small files with an added readme file that contains instructions on how to compile the software, as long as you have a compiler like GCC. And GCC is a tool that helps us to compile software to what the computer can understand, you normally have to run a script called configure, which will be provided as part of the archived files. Now, this configure script would normally contain attributes such as path to libraries required by the software and path on the file system to create new root binaries, which gets created in the process of running the script. And part of what the configure script will do is to check for application dependencies. If there are any major dependencies which are missing, the script will exit and you wouldn't be able to proceed with the installation until these dependencies were met. And this used to be a manual task. Wherever the dependencies are, you'd have to go ahead, look for them, and make it available before you can proceed with the installation. Now, if you manage to get the configure script to execute successfully, another file called makefile would be created. With the makefile, you will then proceed to run a command called make. After completing the make command, you then run another command called make install, obviously with sudo. And at this point, if everything works, you have successfully installed the software. Now, this sounds like a really painful process, and that has led to reinventing how software can be installed on a Linux system. Nowadays, we use what we call packages to remove all these complexities. Packages were invented to simplify software installation on Linux-based systems. A package is basically a collection of files into an archived or compressed file, and within the archived file contains binaries which have been pre-compiled. A package does contain some other metadata such as the software name, the description of its purpose, the version number, list of its dependencies, etc. And depending on the Linux distro, each of them have created their own package format that is easily understood by the respective operating system. For example, packages with the extension .deb are used by Debian, Ubuntu, Linux Mint, and few other distros. Any package that you see that with the extension .rpm is used by Red Hat, CentOS, Fedora, SUSE, and few other distros. And by the way, RPM stands for Red Hat Package Manager because this was developed originally by Red Hat. There's another type of package with the extension .tar.xz. This is used by Arch Linux and a few other distros, even though, as you can see, it's just a compressed tar file or tarball as some people would call it. It is indeed a type of package. Now, with this reinvented way of installing software through packages, a lot of problems are solved. The biggest one being the dependency issues and version management and of course software consistency. In the next lesson, we're going to explore the Debian based package manager because we're working on Ubuntu, and by then most of these things will become clearer. If you haven't subscribed to the channel, don't forget to subscribe, like, share, and comment. See you in the next video.